Testing one, two, three. Hi guys.
Hey, we got it working now. Can you see us?
So is my picture changed since the last time, or not?
No, that's good.
Is it okay?
Sir. Hey, and I appreciate you talking with us and sitting through all this
Oh
difficulties. This
no
is kind of
no. I've
our
gone
first
through
interview, so
way
Yeah.
worse than this. I've done entire interviews where we were the other side was recording and deliberately and they hit the wrong button, and
oh,
so I had to do the interview again for like an hour. That was fun. I mean, that reaction at the end where they're hitting stuff. It's like, oh no.
they're like, oh, we didn't get any
We
of
didn't
it.
we didn't get it. So it's like, ah, great. So that's fine. Anyway,
That's,
so where do you guys want to start? What do you want
yeah,
to?
so we're doing, like I said in the email, we're doing a group project on different like views in science on different theories of like how the world works and kind of like so obviously having seen Behind the Curve on Netflix.
Yeah.
New of you. I was actually kind of stunned when you when you
Very
replied to me.
good.
I just figured we'd reach out to you, but
Oh no, no. I've any university. I mean, I reply to most people anyway, but
mhm,
anybody that's tied to anything that's university age or younger. In
yeah,
fact, I did a Louisiana high school just an hour ago.
really,
Yeah.
that's awesome.
Yeah.
Oh.
So I
Yeah,
do classrooms actually more often than I thought. Did University of Arkansas last week.
hmm
Yeah.
yeah. So University of Tennessee, you can check that one off.
Right on.
Uh,
Yeah, I've not done Tennessee.
there we go. So we'll start with an easy one, I
Yeah.
guess, a curveball.
Yeah.
What is flat Earth theory?
Dun dun dun. Okay, flat Earth theory is basically that you think you're living on a tiny little rock covered with water and smoke flying through space at impossible velocities and endless universe, which again doesn't make any sense. What we're saying
What?
is that you are living in a snow globe, a planetarium, a building with walls and a floor and a ceiling,
Okay.
and even our best and brightest didn't figure it out until about 1960. And so it's not even really an old conspiracy. And when they figured it out, the United States and the Soviet Union, they decided to keep it under wraps for as long as possible, and until they could get an infrastructure built to where they could just tell everybody at the same time. Was the general public ready for it in 1960? No, no, they weren't. Are they ready for it now? Yeah, they are. We've got an infrastructure with high-speed internet, social media, 6 billion smartphones. I think we can address this pretty easily now.
Yeah. Well, you mentioned there, I want to talk about, could you explain maybe the differences between, I mean, like, obviously back in the, I don't even know, 1,000 years ago,
Yeah.
people thought the Earth was flat. And then you said that it wasn't an old theory, but rather than a new one. So could you
Yeah, yeah,
maybe,
yeah. So back in the day, and you can look these up. None of it's secret information. There was you could if you Googled something called ancient cosmology, you'll see that everybody thought they saw the same thing, and that is if you see the stars moving overhead, obviously they're moving and not us, and so everybody drew the same thing. I don't care if it was Viking culture or East Indian or Native American or Aborigine tribes, they all drew the same thing, which was some sort of snow globe, some sort of
yeah.
building. That's what they always drew. And that stayed the same for most of our history. And I don't care if people argue about the Greeks, screw the Greeks, all the way up until about 500 years ago. And that's when the heliocentric model got put into play, the solar system model by
Hmm.
Copernicus.
And you're referring to, yeah, Copernicus.
Yeah,
Cool.
Copernicus, and that's when everything changed. And that's when science started building up its institution. And for the last 5 centuries, that's what science did. They pushed this out there. It's like, okay, we're in a solar system model, everything is spheres, and that's how it is. And that got a lot of traction. What was interesting about that, though, is that there was no way to prove it. Up until if you don't have a space program, and I don't care what you do with geometry, until you have a space program, you don't know anything. So that was one of the questions I put out there. There's a lot of stuff that wasn't put in the documentary, obviously, because you can only do so much in 100 minutes. Which was okay if NASA wasn't even founded until 1958. How did everybody in the world know in 1957 that it was a globe? It wasn't that they knew; it was they were told, and that's basically the long and short of it. It was. Did you lose me for a second?
Yeah, we lost you
Yeah.
for about 30 seconds there.
Oh no! What was I talking about?
Yeah. Sorry, I'm sorry.
What was the question again?
No, we were talking about the difference between flat Earth and ancient flat Earth, and we got to
Oh yeah,
the
yeah, yeah.
Copernicus.
So
Yeah.
the short version is this: is that up until you have a space program, what do you really know? What do you really know? How do you really know? In fact, George Orwell, who wrote 1984, said this wonderful quote. In fact, let me kill off my email just so I can make sure I get rid of all bandwidth.
That's what we
all,
did. We just closed off the email
all
to make
bandwidth
sure
is
it's
going
good.
yeah, we'll make sure we don't lose anything here. So George Orwell said it was really interesting. He wrote this in 1946. He said, "How did everybody in the world know that it's a globe? You could ask anyone on the street." He goes, and the first impulse is always the same, which is, well, we just know. Duh, everyone knows this. Like, how do you know? And then people get mad if you push that to them, and they know they don't know. That was just it. NASA wasn't even founded until 1958. So, and the reason is because there's a globe sitting in your classroom from the time you were 6 until at least the time you graduate from high school. It's 12 years of sitting in your classroom, and that's it. It's not that you know that it's a globe; you're told that it's a globe, and that's how it goes. And so that's the big. So yes, it is a recent conspiracy as of late. But it was all. But for most of our civilization, that's what people believed. It's actually very, very recent that that all of the world even got on board with it. You got to remember, 500 years ago, the majority of the population couldn't even read and write.
Yeah.
So what do you just tell people this again? It is. I use the line from the Truman Show, and that is, "We believe the world that is presented to us." Which is why, again, if you want to see a really weird movie, go watch The Village by M. Night Shyamalan.
It's actually a good movie.
Yeah, where basically they tell the kids. Here's the interesting part about the movie: you tell the kids that it's the 1800s and you're living in a community in a forest and there's monsters outside. Well, when those parents die, because it was the parents that knew it wasn't true. Technically, when the parents die, nobody's lying anymore. It's all true. Everybody in that town could pass a lie detector test. So again, the truth, the lie becomes the reality. So.
Okay. Well, I guess you're kind of just leading in for me. What motivation, like, would there be for NASA or I don't know, like the world governments to come together? And
at least 1 out of every 10 people ask me that. What? Why? Yeah. Why would you do it? And it was like, what would they have to gain? That's what most people think. It's like, no, it's not what you have to gain. It's what you have to lose. Because remember, we're talking about if you don't figure this out until 1960, your civilization's built. All the infrastructure is already there. You're just trying to hold on to what you have. So think about what happens if you tell people in 1960. It's three things could go wrong, and they're all horrible. First would be academic. Every university in every state in every country would be turned upside down. Libraries would have to be emptied out because forget about astronomy and astrophysics. Think of all the remaining physical sciences, biology, hydrology, geology, archaeology. They would literally have to be rebuilt. That's just academia. I mean, it would just be chaos. World markets, world stock markets have to be suspended for months. I mean, for God's sake, look what the coronavirus is doing to the markets, right? Like that's just a freaking bug. You do this, the markets they panic in the streets, potentially. But the big one is the religious side, which is you're telling the 5 major religious houses of the world, Judaism, Hinduism, Buddhism, Islam, and Christianity. You're telling them you now have leverage against science again. And you think they're going to show restraint. They are not. They are going to be like, oh, it's payback time. And they will come after him. And that'll just be the beginning. They'll go after evolution. They'll go after the Big Bang Theory. They'll go after all astrophysics. They'll go after everything. Yeah. And so it's a short meeting. So why would you keep this thing a secret? That's why. The people in power don't like chaos unless they control it. And that's what you're talking about here.
Yeah, that makes sense. Shelby, did you want to get him with one?
I kind of want to talk about gravity. So So do you believe that gravity exists?
Yes.
Or you do?
Oh, yeah. It's not, again, it's one of those common things that people throw out about the flat Earth community. One is that we're in this giant flat space asteroid, which makes no sense. Because we don't believe in space, period. You know, snow log could be just sitting on your desk. You don't need space.
Could you talk a little bit about that?
Sure. So if it is this, if you are living in a building and structure, You don't need anything else. It's that easy. Meaning, you gotta remember the globe model needs a huge amount of support to keep it going. You need a solar system with a sun, you need a galaxy around that and a universe around that, and you need a huge amount of geometry and trigonometry and quantum mechanics and calculus and all this other crap. Whereas this thing, you need nothing. You need some algebra, maybe a little bit of geometry, but not much. And as far as gravity goes, the common misconception is that we don't believe in gravity. It's not that at all. But it's not just gravity that keeps things going. In fact, your leading scientist, you can ask any scientist in your university, they'll say, give me a definition of gravity. They won't be able to. They will say, no, we can't tell you what gravity is. We can only tell you what it does. We can only tell you the symptoms of it. You know, you drop something, right? You know, it falls. You can do this all day long. We can do that. Oh, it proves that something's happening. But they'll say, well, it's this magical, invisible molecular force that pulls things down to the center of a globe. Really, it's not that much different than what I believe. I think it's a magical molecular force that pulls things straight down to some sort of flat surface. But if it is this, if it is pressurized, you know, if it is, that's the big thing is a pressurized system, then it's not just gravity. It's also density, buoyancy, which means you take a volleyball or a water polo ball. Do you have water polo in your university? Probably. Okay. Yeah, you push it down. Why does it pop back up? Well, because of density. You know, the air is less dense than the water around it, so it's going to pop back up. And if you filled it with helium, it would just keep going. So what's my point there? My point is pressure and density factor into a lot of this. Here's goes to your gravity question. What is more powerful, gravity or vacuum? It's a vacuum all day long. Gravity cannot ever win against a vacuum. When you take a straw and you suck a soda out of a glass, why didn't gravity keep that soda in the glass? Well, it's because your mouth was stronger than the gravity that was holding that down. Take that one step further. Let's say there's a second floor to your building right now, right? And you turn that into a small vacuum chamber with a cork in the ceiling right now. You pop it. What happens? You know what's going to happen. It's going to be instant. It's going to be violent. It's no different than blowing up a balloon and letting it go. It's always going to run off because the air is going to try to get out of that thing. And you're going to say, what's your point? My point is, why didn't gravity keep the air in your room right now? Why did it go upstairs? Well, because vacuum always wins. Always. No, you look up some wonderful videos on YouTube. One is called, the Germans love doing this. I don't know why. They get a weird fascination from it. Vacuum versus a steel rail car. Take a steel rail car, apply a vacuum field to the inside of it. It's just instant. It's like a freaking monster just crushed it. Just like, yeah. It's like, wow. It's not like the movies. The movies, you're dead. I don't know. Any movie you watch, it's like, we're running out of air. Get the suits. You're dead. The only reason they let the people live is because they just take dramatic license. So here's the question. So if gravity didn't keep the air in your room right now, instead of going upstairs, then why is there air outside? Mm-hmm. You're going to come back and you're going to say, oh, gravity. It's like, oh, no. Same gravity. Exact same gravity. Then it's in your room that's 20 feet outside. So why doesn't the vacuum of space just rip our atmosphere completely off? And you say, there is no answer. And science will not be able to tell you. They'll say, in fact, you can come back and say, where exactly is the edge of space? You've all heard that term, right? Where does our atmosphere end and vacuum begin? It absolutely defies what thermodynamics is, which is you can't have pressure next to non-pressure without a barrier. Enter barrier. That's what it is. Then the reason why it works, the only reason it works, is because it's a pressurized system. So does gravity exist? Yeah. Is it just part of the equation? Yeah, it's a two-part.
Okay, so what is that barrier in the flat Earth model? Like, what is it
made out of?
Yeah.
Come on, man. Okay. Well, no. Yeah, I know you have to ask, but for me, oh my God, it's one of, I don't know, 10 things that it could be. It could be high frequency. It could be a force field. Could it be a unified field? Could it be a heavy element? Could it be a heavy water? Could it be something unknown? All I know is that we tried to bust through it for 4 years. The United States and Soviet Union hit it with everything they had from 68 until 72. Wait, was that right? No, sorry. Wow, back up, wrong decade. 59 through 62. 68, and it was 4 years. It doesn't really matter. They both shut down at the same time. They were using megaton weapons back, the early shots, and then they used medium range kiloton weapons. So the question is, if atomic weapons can't get through it, whatever it is extremely, it's something we haven't seen, we don't know about. Because atomic weapons can vaporize anything that we make, literally vaporize any element that we have. So my guess is it's an element or an energy field that we don't have the engineering to do.
Okay. Okay, cool. Yeah, I mean, some of these questions you just gotta ask.
No, it's fine. It's fine.
I'm sure,
again, I get that question all the time. Right. It's like, look, I don't know, but I can tell you. I mean, if you watch enough science fiction, you're gonna have some ideas about it. But whatever it is, it's engineering. The engineering capabilities. Whoever built this was not us, and whoever it is really, really powerful and really, really old. So I wouldn't mess with them.
Yeah, I guess you touched on that. Who would you, I guess, assume that it's God or like what? Who?
Well, you can go down one of two paths, but really you're just splitting hairs because you could say, well, it's either one of two things. It's either an older civilization that's much more powerful than ourselves, not a big shock. You know, we've written about that in science fiction forever, or it's a deity. And again, you know, I'm not going to name God in this case because there are 5 major religious houses. So the thing is, though, you're really just splitting hairs because one man's ancient civilization is another man's deity. If a giant golden spaceship just parked itself somewhere, you know, and 10-foot tall blue people came out, oh yeah, there'd be some people, it's like, oh wow, they are like Avatar. But there's other people that would actually start a church, like immediately. They'd be like, we must bow down and serve the blue people. You know, it's like, gather, hey, around everyone. And that's how it would start.
That's funny.
So I'm a little bit confused of how like other planets are involved in this dome.
Planets.
So how do you explain like other planets like Jupiter and stuff like that?
No, it's fine. Okay, and again, the only reason you're even asking that question is because you've been reinforced like everybody else that space, you know. It's like space is a thing. I mean, it's amazing. In fact, since we've been doing this for the last 5 years, every single day there's a new space story. It's basically a drumbeat.
Yeah.
And they don't care, just so you know, they don't care if you even read the title as long as you look at the image. I mean, you might glance at the title, but it's like, look, there's something new about the spot on Jupiter. Hey, there's a face on Mars. Hey, there's something on the top of Saturn. They don't care about that. All they care about is if you're thinking about Jupiter, you're thinking you're on a globe and everything else. Do the planets look spherical? Yes, they do. Are they actually spherical? They might be. Can you land on them? No, not a chance. They're just lights on a ceiling. I don't know if Tennessee has the University of Tennessee has a planetarium, but if you ever get a chance,
I think we do. Yeah.
Go and stare at these things because you know the new planetariums, if they have a decent projection system, are really quite good. And you know you see the planets and the stars and meteors, and you can even see the moon going overhead. So the question is like, oh wow, does the moon look spherical? Yeah, it does. Can you land on it? No. And I say, why not? And you say, well, because it's just an image on the ceiling. And I go, yeah. Who's to say when you walk out of that building, you're just not in a much bigger building? That's all we're talking about here. I mean, you could take, let's face it, you could take people from 100 years ago, put them in that planetarium, you know, blindfold them and put them in there. They'd think they were looking at the night sky. You could tell them anything you want. It's like, oh, that's absolutely the night sky. They'd believe it. Absolutely. So who's to say that you can't fool a whole population if you didn't, you know, if you wanted to? Don't forget that the technology we have now is still really, really limited. Yeah, we're talking on cool stuff right now. But we 20 years ago, we didn't even have HD television, right? And people like, and 20 years ago, the internet was really, really slow. So imagine what would happen, and we have 4K televisions right now. Imagine if you had the technology to build a 1,000,000K television, what you could do with that. So yeah, everything you see up in the sky, short version is everything up in the sky is just part of a pretty display system and the oldest clock ever built. Really, that's all it is. It's a pretty clock.
Okay, cool. I think, yeah, so let's talk about the sun. I did a little research on the, I guess, Flat Earth Society website.
Oh, don't look at them. Just so you know, the Flat Earth Society, that's a good thing you brought it. I'm glad you brought this up, has nothing to do with anybody that has any work on social media right now. For some reason, the original Flat Earth Society, which was been around for a long time and kind of kept up when the internet was going on, But then they just, for whatever reason, just went dormant and nobody did anything until about 2015 when we decided, people in social media, we were just going to do stuff on our own. And in fact, no, I don't even know. We've done, I don't know how many different conferences in different countries and meetups. I've never actually met someone from the Flat Earth Society. Everybody that's anybody that's doing anything is all social media based. So if they are 1.0, we're 2.0. We don't even talk to them. So I literally don't know anybody in it.
Well, I'll just scratch that question then.
No, it's okay.
It's all good. It was about like the sun being.
You can still, whatever they say on their website, it doesn't really matter to us because we started from scratch. We did not use them as a resource. In fact, they were the ones that said that some of them were saying that flat Earth is actually a disk in space that's simulating gravity by traveling upwards at 9 meters per second. Nobody I know goes into that at all. It's like, look, it's a self-contained thing, and what's outside it, whatever it is, it's not space. What did they say about the sun? I haven't heard anything.
Well, that's what I was going to talk about.
Go ahead.
It just was saying that it was accelerated up due to the dark energy, but then also I was just going to talk about the sun being 3,000 miles away and 32 miles in diameter by their model.
Oh, no, that's fine. That's fine. Actually, that part, I mean, we don't disagree with everything that they do. But yeah, we actually came up with that on our own, which is the sun and the moon are very small. They're less than 50 miles wide. Do we know the exact dimensions? Of course not. And how high up are they? I mean, the atomic weapon tests were capping out at 400 kilometers. Could this thing be pushing 3,000 kilometers high? Maybe. I mean, whatever it is. In fact, the arc of this is probably way diminished because it'd be really, really shallow. It'd look like a shallow sports stadium because remember, most of our technology, commercial airlines cap out at not even 10 miles high. Spy planes maybe twice that. So even if the ceiling was only 400 or 500 miles high, we'd never reach it. Well, the civilian market would never reach it, which NASA comes into play afterwards. We might get it to that, or maybe not.
Okay. Well, I guess. So as a flat earther, do you dispel, I guess, all science, or do you accept, I don't know, so for instance, nuclear science, how the sun works, or
No, not at all. Okay. There's a couple things there we should probably clarify. I love science, always did. Everybody that gets into the flat Earth, I was a techie, in tech support for years and years and years. So I think science is great. Science but science is corruptible like anybody else. They have made decisions and taken leaps of faith and made statements that are very, very broad that they shouldn't have. So when Neil Tyson says that science is true whether or not you believe in it, yeah, well, that's not accurate at all, because science is only true until the day it's not. They make statements, and basically what they used to say, this is our best guess. Now they don't say that anymore. It's like, this is how it is. Stamp. And that's it. And it's like, okay, which is why in my speech last year I talked about the stupid coelacanth fish, which is a great example. It's a fossilized fish extinct for 70 million years. And every scientist in the world, every single one of them would have bet the frickin' farm that was absolutely accurate. It's like, we got the fossils. It's obviously jibes, our carbon dating, blah, blah, blah. Dead 70 million years. It's like, great.
Yeah.
So why did the British government just catch one off of South Africa and then another one off of Madagascar and Mozambique, and then National Geographic swimming around with them taking movies? It's like, how did you get it that wrong? How did you screw this up that bad? And they said, well, we don't know. It's a living fossil, and it's in an evolutionary state of stasis. And they just started making up terms. So the question is, how did they screw it up? They screwed up because they saw that they don't ever recheck their own work. You all right there? You got the virus? You really?
Oh no, I hope not. Don't say that. You're just talking to her on the screen.
I'm pretty sure it could be transmitted via email too. No. So here's the thing. So how'd they get that wrong? It's because they rarely check the original work. All scientists build on each other's work, and they assume that whoever came before them was absolutely right. So do I believe science makes mistakes? Everybody knows this. And then they kind of backpedal and do have to do things later. Where they take massive leaps is when it comes to astrophysics. Massive, massive, massive leaps. Which is why in my clues, and I don't know if you watched them, when I talk about the core of the Earth, it's like, here's the thing. If the average person can physically verify most of the data, great, fantastic. Boiling temperature of water at sea level, great. Do that all day long. Tell me what the core of the Earth looks like. And it's like, okay, you know, you got these wonderful cross sections with perfect 1,000-mile bands of red and orange and yellow and white. It's like, how'd you get that? And it's like, what? It's like, how'd you get that diagram? And because the deepest hole ever drilled is 8 miles, ever. And no one can get past 8 miles for whatever reason. I don't care if it's magma or not. You still can't get past 8 miles. So how are you showing this cross section? And not only that, you're showing us the cross section of Jupiter and Saturn and Neptune and planets that are outside the solar. How are you showing us this? And then if you look in the fine print, they say, oh, well, we're just extrapolating. We're making an estimated guess. It's like, so you don't know. It's like, no, we don't. The thing is, science doesn't like putting question marks in textbooks. They don't do it. The globe, if you believe in the globe, should be this giant question mark on the inside of it. They won't do that because they don't want people to bug them with questions. So they just say, this is our best guess. That's it. We're leaving. That's it. We're just revisiting this. So again, science. So when you talk about the thermal nuclear reaction of the sun, forget about that. Tell me how they got the size of the sun.
Yeah.
Tell me they did. Geometry? If you look it up, you go back in the history books, they got the size. They just guessed. They said, well, sticks and shadows, it's got to be 93 million miles away, and it's got to be a thermal nuclear reaction that's continuing for blah, blah, blah. It's like, do you know? You didn't even have telescopes that could even look. I mean, you know, the closest nearby star is supposedly 4 light years away, which is, by the way, a ridiculous distance. People don't even know. I mean, the distances they talk about the universe. Even Carl Sagan, you know, the old sage, you know, even he was the first to say, wow, universe doesn't make sense because it's so freaking empty. If you believe the distances. Yeah, it's empty. And we don't say it's empty. We say it's not even there. It's just this painting on a ceiling that we just start making stuff up. Anyway, go ahead.
I guess you do get kind of just familiar with the distances they throw out. Like it's just, you know, like light years and stuff.
Do you know how, I mean, here, if you believe their distances, the reason they say light years is because if they try to do it in miles, it becomes, you just start getting dizzy. Like they say light is 186,000 miles a second, right? The reason they have to say that is because if you go up one notch, it's 720 million miles an hour. That number means nothing to anybody. In fact, I even question the speed of light as it is because of what we do in simulations. You know, I do question. I was like, speed of light, really? Where are you getting that from exactly?
Yeah, so tell me about that, I guess. Speed of light.
The speed of,
I mean, we've all heard speed of light since since we were in eighth grade probably.
Oh yeah. Speed of light, for me, you got to remember, I'm a big believer in simulation theory. I mean, yeah, I start off with flat earth because flat earth resonates with people. Because for whatever reason, we have a really hard time explaining simulations that we're building now. We have a hard time explaining to people for whatever reason. You know, people play games. You know, you have your friends. You play GTA and Fortnite and Minecraft and all that stuff. Oh, and by the way, those games are built. This is a big key here. Those games are built on completely flat surfaces. They're boxes. In fact, it's not even a dome. It's just a big box. It's like a cake box with a shallow ceiling. In fact, the sky is not even a circle. It's called a skybox system, which they simulate into a circle. And the reason is because computers can't draw circles. You say, no, computers can draw. No, they can't. Like if you look at it, why is a pixel a square? It's because that's the only thing you can tell a computer to do. It's like right angles. That's all it is. So when it comes to the speed of light, I question it because simulations, we can make light do anything we want. And light is instantaneous in simulations as well, to the point where the speed of light means nothing in it. So again, when people talk about, you know, I'm digressing here, but when astrophysicists start just going off into the weeds about with all these numbers, they're losing their audience because the audience think, well, these guys obviously are smarter than me, so I'm just going to let them just talk about it. So when they talk about, you know, the oldest question there is, you know, like the Big Bang, right? What came before the Big Bang? Well, it was a really, really big bang. It's like, yeah, I got that part. It was really, really fast. What happened before it? They're not going to answer it. They have their own creation story, and now they're working on dark matter. There's physicists all over the place that are trying to fill in the gaps of dark matter. It's an absolute, it's an even worse theory than gravity. Which is, it's like they're literally just trying to make it up because they don't know. There's so much of the universe, their perceived universe, that doesn't make sense. They just keep trying to add things to it to make the math add up. It's like, why? You're never going to get, even the best case. We haven't even gone to Mars, for God's sakes. If you even believe the moon story. By the way, that's a whole, I could go in so many different directions. But here's one for you, which is, so the Americans went to the moon, right?
Yeah.
Last trip was 1972.
Mm-hmm.
Why didn't anybody go back? Ever. From anywhere.
It's expensive.
Expensive? Really? No competition? No space agencies? It's 2020. And here's the other thing. You could look up, there's wonderful compilations. Every president since Reagan says we were going back. Since Reagan. It's like, we're committed to going back to the moon. Next term, we're committed to going back to the moon. Clinton, next Bush, Obama, Trump. They're all saying it. Why hasn't anyone gone back? Because they can't fake it. They tried, and in fact, I could give you here. Let me give you something real quick while you're thinking of your next question. 1 second. You will like this. Sergeant Files 20.
I gotta get to.
Here, look at. I'll probably lose you for 1 second when I do this, but I gotta. Hang on. Moon curve. Okay, so here, take a look at this. I just dropped this in your. I'm going to lose you for 1 second when it uploads. Okay, so that's a shot. This is just a random shot from Apollo 12. Right. Here's the reason why nobody's been back to the moon. I can see at least half a dozen things wrong with this image, and you could do it too. And that's just a straight up NASA image, right? Nothing special about it, right? Two astronauts on the moon at a given time. So what's wrong with this? Well, forget about the stars. We won't even go into the stars thing. The fact there aren't any stars anywhere from any of the shots ever. They say, and camera guys will come back. Well, it's the exposure settings. They had to shoot it like that. So they didn't take a roll and set it to the right settings to actually shoot stars, because there's an atmosphere. It would be the most beautiful setting of stars ever.
Yeah.
Shadows only go in one direction if there's one light source, being the sun. But the shadows are going in 4 directions in this, and this is not a time-lapse shot. There's no blast crater underneath that module. There should be. The VHF transmitter, that little satellite dish, that's from 1969, right? It has a range of maybe 50 miles, and that's Morse code, 50 miles. And they supposedly did 10 frames of color video a second with two-way communication, with pinpoint accuracy, with no distortion whatsoever, never in a million years. The astronaut suit, one of my favorites. That also defies the laws of physics, because remember, why doesn't an astronaut suit turn into a basketball? Meaning, pressure. And you can look up any video you want online, anything in a vacuum chamber. If it's a soft container, it goes rigid and then it eventually explodes. No different than a basketball. So why does that astronaut can he move his elbows and knees and fingers? Why can he bounce around? Why didn't he turn into a parade float and tip over and die? No one ever talks about it. Ever. And it just goes on and on and on. There's all sorts of fun things. And that's just one freaking photo. That's why no one's been back to the moon. Is because the photos from the 60s have aged so terribly that they don't know what to do. Sorry, I go up. Keep me on point here. You have a list of questions. Go.
Oh no, we don't. We're about at the end of questions anyway, so really you're just.
Oh, I'm just freelancing it.
Check me on the topic. We appreciate it.
Okay. Well, no, it's fine. I mean, another thing. Think about this. It's the stuff. Sometimes it's not the stuff that we show people. It's the stuff that's left out. So, for example, you know anyone that scuba dives?
Oh yeah.
Okay, perfect. What's the only thing that scuba divers care about? Air. That's all I care about. They look at their gauge. It's like, how much air do I have left? How much air? They're constantly checking that. And at some point, it's like, well, it's less than 10 minutes. I gotta get the hell out of here. And then they leave. Find me a single audio clip or video clip of any astronaut saying how much air they have left. How did it happen? There's no. I forget about the vacuum part. It's like no astronaut even cared how much air they had. They had an unlimited supply of air, constantly running around, building their car, playing golf, jumping up and down, setting up the flag. No one cared. It's like, hey, Fred, I got 13 minutes of air left. I think I'm gonna go back to the lander. No one ever talks about it, ever. And it's like in 1969, are you kidding? If you land on the moon, that's the part that just drove me insane. If you land on the moon, you're looking back at Earth, the only thing you care about is not dying. That's it. You look at it's like, how do I get back? Holy smokes, I'm freaking out. That's all you're going to do is you're going to care about not dying. And yet that never, ever, ever happened. The moon missions, and again, remember, we were the ones that tore into the moon missions more than most, but even the Americans started tearing into them like immediately afterwards. It was the nerds, the super nerds looking. It's like, wow, that geometrically doesn't line up at all, and so people started making fun of this ever since the 70s. But until the internet came out, it didn't really get spread. So that's what we tear into first. We go after NASA and we say, which is why I do the spacesuit thing. I go, if the spacesuit is wrong, if it's absolutely an engineering nightmare, then anything that ever shows a spacesuit is wrong, which means everything.
Yeah. Okay. So. Well, do you remember when they actually went to the moon? Because I'm assuming you were a child, or
I was just born, but thank you.
Oh, okay. Well, I mean, my dad.
Oh yeah, back in the day. Hey, you think think I knew Lincoln? Come on. Blue and the gray, brother versus brother.
I'm sorry. Okay. Do you have any more for him, Shelby?
No. Let me tell you about the moon mission though. Here's the reason why it worked. The moon mission was brilliant, and you can look up some other things on the moon mission, like the early spacesuits that they tested were these huge, rigid metal and plastic things. Because again, they knew what would happen with a vacuum, but they were really clunky. They looked like movie nightmares. It's like you couldn't walk in them, let alone it's like, how are we going to get them into a spacecraft? These things are never going to work. And then someone comes along and they say, you know what? Give them a soft spacesuit. Really? How are we going to do that? It's like nobody knows anything about physics, and it's true. Nobody knows anything about physics. It's like no one's going to know. We'll be able to do it. Put it on television. They'll buy it. It'll totally work, and it did. That was brilliant. It was a huge risk, but absolutely it worked because, again, you guys notwithstanding, the average person on the street knows nothing about physics, engineering, chemistry, any of the major sciences. They know nothing about these things. So like the moon thing, the shadows. Again, it's something you have to revisit. It's like shadows going.
You wouldn't even think about that if you do it. You wouldn't even think about that.
No, you wouldn't. It's like shadows only go in one direction. It's like, oh, wow. Yeah, so why are they going in four directions? It's like, I don't know. It's like, well, they shouldn't. There's only one of two answers. Either there's a light source, they brought their own stage lighting and they put it right behind them, which makes total sense. Or the light source is really, really close, and that's it. And so it was filmed on a stage. It was absolutely brilliant. And we bought it because it's on television. We have a huge disconnect. And now it's much worse because your generations... whatever's on your smartphone, whatever's coming across. I mean, you guys give legitimacy to people that have 1 million subs on YouTube. Complete legitimacy to them. You'll give more credit to freaking PewDiePie. I know he's older, but than you will an anchor at CNN that's been doing it for 20 years. Why? Well, because PewDiePie's got 100 million subs. Well, he can buy subs, right? You can buy that. Yeah, well, it doesn't matter. He's totally legit, and it's like. Maybe. So
that is just the society nowadays. All right, this is the last one.
Okay.
That we're going to talk about, and then we're going to let you go. We appreciate you.
Oh yeah.
Joining us. So Michelson and Morley experiment. Tell me what about.
Got it. The Michelson-Morley experiment. Also, you could if you're going to look up that one, you could look up Airy's failure, which is right along those lines, because they both tried to prove the same thing. In fact, I like Airy's failure better. But Michael Morks is fine. But I like Airy's failure because of what he said at the end, which was they were trying to prove the ether. They were trying to prove that it was kind of like the early versions of dark matter. Actually, that we were flying through space and you could measure the cosmic winds that were going by, and therefore prove that there was some sort of we were traveling through this weird space ether. And neither of them did it. They were going, well, that doesn't make any damn sense. The experiment failed miserably. In fact, Airy's failure was interesting because he said he was a quote that he had. I'm going to butcher the quote, but it's something to this effect. Either he said, either I failed or the Earth's not moving. And he goes, but we all know that's silly because the Earth is moving, so I had to have failed. And it's like, because he made that assumption. Again, we're talking about one of the early scientists. It's like, well, he assumed that the Earth was moving through space, but since he failed his experiments, like, well, he assumed that was a given, that was absolutely the concrete fact. And it's like, no, it's not. So he didn't fail at all. You know, so yeah, when
to accept his evidence that he got.
Yeah, I mean, in fact, there's so many other people that have kind of hinted at it. That like Nikola Tesla has said that this world is more of a realm than anything else, which I thought was interesting. Of course, his work was disputed for a long, long time, and he's a weird guy to begin with, so his credibility, who knows. But yeah, it's a strange concept, and I don't know. I mean, I know why it's resonating. I know why it keeps getting bigger and bigger, because we figured out a way to explain the world that's easier than the solar system model, and people love easy, plain and simple. I mean, it is, you know, this is way, way easier to explain. It's like, well, and people have come back, so like, just because it's easier doesn't mean it's right. It's like, well, no, but if it makes sense to people, then it will become right. And that scares the hell out of science, because they don't know what to do with that. And so, like, look, it's just the way it is. Like, you made the solar system and everything so complex that we're just stepping in and saying, look, could be this. Why not? In fact, it makes more sense like this, and that's why it just keeps rolling along.
Well, I guess that's oh, actually, wait. Do you know about LIGO, the gravitational wave thing?
Oh my God, that dog and pony
that,
show.
That is a Michelson and Morley experiment, just like really to
yeah. Okay, look into I watched some of that. Look into the details surrounding that, because remember, they were up for funding renewal just before their observations were detected. And as you know, again, not to say that scientists are corrupt, but things happen for the money. And that is like, wait, our funding's going to get... If someone comes to you, and again, you can talk to scientists and pose this question to them, and they'll be like, which is, if someone comes to you and says, our funding is going to get pulled unless we can discover gravitational waves really, really soon, what do you think is going to happen? You're either going to do the right thing and say, well, never did figure that one out, and you know, then you lose your funding. I mean, come on, scientists need Porsches too. And that's what we're really talking about here. I mean, scientists will, I'm not saying that all of science is corrupt. No, they're better than business and politics and sports and entertainment and journalism. But come on, they cut corners for the money. As many times, I mean, again, you know, lead paint, lead gasoline, DDT, all the variations of DDT, asbestos, which is a great product, unless you work in the factory, then it's not so great. Cigarettes, I mean, come on. It wasn't that long ago that scientists took the money and published papers saying, cigarettes are fine, totally fine. So no. Anyone the gravitational waves thing, in fact, they retracted it not that long afterwards. After they got the funding. They got the funding, it's like, well, our revised results weren't exactly good, so you lied. You lied to get the funding, but you know, they weren't going to take the money back. It's like, well, we'll get it this next time. It's like, yeah, sure you will. Sure you will. So.
All right. Well, Mark, do you have anything else for me?
I know, I'm good.
Mark, you've been awesome. We appreciate it.
Oh, no. Thank you, guys. And if you need any other resources or memes or images, do you want me to send you like a...
yeah, you got to send me your best memes. I'm gonna have to see those.
Okay. I'll send you the the slideshow collection I got, and I'll send it right after I hang up, and then you can do with it what you want.
Awesome, Mark. You've been awesome. I appreciate it, and I'll get in touch. I'll let you know when we're done with our presentation. I'll send you a copy.
Okay.
Awesome. Thank you so much.
Thank you, guys.
Bye.
Bye.
See ya.